Good afternoon. I'm Barry Cross with Optech, and I'm here today speaking on behalf of JY Park. JY is the manager of software development at Optech's Kiln, Mississippi office, which is where we develop our bathymetric LIDAR capability. So in Kiln, we basically implemented the seasonal bathymetric LIDAR system for Geospatial, and that's the coastal zone mapping and imaging LIDAR. I had an ongoing conversation with JY about this topic as I previously supported the voxel analyst product earlier in my career. So moving on here to looking at the waveform technology, seasonal is a 9-channel system, and we create a composite waveform using multiple channels of this system. And this is kind of the normalized version, and what we're going to do is use these to generate the voxel model. So this is essentially our 3-dimensional or even 4-dimensional data samples that we're going to use to generate the voxel elements. And so in this case, seasonal collects about 90,000 points per second, 90,000 waveforms that is. And again, these are created into a composite and used to generate the voxel model. In this case, the resolution is 1.5 meters in the horizontal and about 10 centimeters in the vertical dimension. This is basically hydrofusion interface for seasonal, and this is where you basically will define your area to exploit the waveform. And so we're selecting this area, which is from a data set collected in 2005 when we were doing some test range for the Navy. And so once you select your area, you proceed to bring up the waveform visualization tool. And this allows you, once generated, to slice through that voxel data set and identify aberrations within the volume. And so once they are identified, you can then access the original waveforms, both in a deep channel as well as a shallow channel, and take a closer look at the phenomenology that's resulting in that potential object detection. Finally, I'm ending on a slide which talks about the depth penetration of bathymetric LIDAR. We've really settled at Optech on using what's called the KD-max product, where K is the diffusion attenuation coefficient and D-max is the maximum depth penetration. This gives us the ability in a normalized way to look at performance of bathymetric LIDAR system over a range of turbidity conditions. So if you all have questions right now, I can take, I think, 1 or 2. Otherwise, you're free to please come by our booth 704.